Good day, everyone, and welcome to today's Devops.com webinar. We're excited that you're here with us. Our topic is security across the cloud-native continuum. We have two great speakers lined up for you. My name is Mitch Ashley, and I'll serve as your host and moderator for the webinar. A few housekeeping items. We are recording the webinar, and we will send out an email with a link to the recording and to the slides. You'll also be able to get those downloaded at devops.com. Our speakers love questions. We would really appreciate your questions to the speakers. So please put those into the questions tab of the GoToWebinar software, and we'll be happy to get to those questions during or towards the end of the webinar. Now let's move to our topic: security across the cloud-native cloud-native continuum. It's my pleasure to introduce our two speakers for today. First is Doug Cahill, Senior Analyst and Group Practice Director at ESG. And we have with us John Morello, VP Product from Palo Alto Networks. Doug, let's turn it over to you.
Great, Mitch, thanks very much. And thanks everybody for joining today's webinar. I love talking about this topic. It is so central to so many organizations that are now on their journey to developing and delivering cloud-native applications. And, as an industry analyst, part of the fun I get to do is to share with you, and we're going to be doing this on the webinar today, is the results of peer-level market research. So we recently conducted a study that we entitled Leveraging DevSecOps to Secure Cloud-Native Organizations, Cloud-Native Applications. And it looked at things like the composition of cloud-native applications, the challenges associated with securing those applications. And we quickly moved from sort of, glass half full to glass half empty to glass half full, talk about solutions and how to employ a secure DevOps program to secure those applications. And so John Morello and I are going to spend a good part of today's webinar really focused on the positive side of the ledger here. Really, how can we focus on securing the cloud-native continuum by securing everything from pre-deployment to runtime to better protect our cloud-native assets that are running in various environments. So with that, I think since we're talking about cloud native, a definition is probably in order. So I'm just going to offer up a definition for the purposes of this webinar of cloud native applications being those that are built on an elastic microservices-based architecture and managed via Agile DevOps processes. So sort of one-dose technology, but equally important to be sure is one-dose process. And when I think about organizations that, again, are on their journey to cloud-native applications, there really is a need to retool the fundamental pillars, the people, process, and technology pillars of a cybersecurity program. And so thematically, we'll hit upon those three dimensions here over the course of the webinar. Now, one of the things about cloud-native, however, is it does not necessarily mean that cloud-native applications are deployed in and delivered from a public cloud. What do I mean by that? Well, one of the questions we asked in that survey that I mentioned at the outset is where containerized applications are deployed today and where they're going to be deployed moving forward. So you can see on the left-hand side that, a fair amount of organizations, 39%, do start by delivering their cloud-based applications from a public cloud environment. But over time, moving forward into the future, with this is in a 12 to 24-month time frame, we see on the right-hand side that a lot of organizations want optionality. We go from 23% of organizations who share that their container-based applications were deployed in a combination of public and private clouds to 46% over time. So when the data came back from the field a couple of months ago and I was looking at this, geez, that's really interesting. I had sort of thought container-based applications were, really tightly associated with being delivered from public clouds. But really, when you think about one of the fundamental value propositions of containers, it's portability, right? You want that flexibility where your containers are going to be deployed. You can move these things around easily. I think the other thing that's going on here is that some organizations are developing a core competency on the orchestration tier, on Kubernetes, and they're standing up their own kube clusters on-prem, and that is representing their version of a private cloud. We all sort of stubbed our toe, or many organizations stubbed their toe on OpenStack implementations, and Kube really has sort of come to save the day as being a more realistic version of a private cloud. So I think that's what we're seeing here is some organizations are going to operate their own private cloud, and some organizations just want optionality that frankly probably aren't necessarily sure where their containerized apps are going to be deployed from, but nonetheless they want that flexibility moving forward. And that's why when we think about cloud native, it does not necessarily mean public cloud delivered, it means public and private cloud. Okay, So with that said, let's get into some of the other dynamics around the composition of cloud native applications. What are the technologies that make up a cloud native apps? And, we'll start with containers. Now, we did a similar study 2 years ago. So in 2017, we asked this very same question, hey, do you have containerized applications running in production? And back then, 56% of the respondents indicated that they either had an extensive number of apps that were containerized in prod or a limited number. Most of the 56% were sort of limited at that point in time. So fast forward 2 years, here to 2019, that jumped 20 points to 76%. So no question, containers have moved from dev and test environments into production. Why? Agility. So another question we asked is, what's the benefit you're getting from running containerized applications in production? 37% report that this allows them to beat their schedules. They are significantly ahead of application deployment schedules. That's business agility. What about serverless? So I mentioned we did a study 2 years ago, and we didn't ask about serverless 2 years ago. It was just too early. Even the term is a bit of a head scratcher. We needed the market to mature and organizations to really start to understand what an event-driven serverless-based programming model is. So we did ask that question here in 2019. And for those organizations that are down their cloud native journey, right? So they've done some containerization, maybe they're running some workloads in a public cloud. 35% of those organizations are already doing serverless pretty extensively. Another 18% doing it limited. The reason I highlighted the 28% that are evaluating is there are those that are still getting their head wrapped around, really need to understand the notion of serverless. Okay, so I'm not running a server, the CSP is running the server, it's event-driven, it's API, so there's still a need for market education. But the hyperscale CSPs have really done a great job in talking about the benefits of serverless, both security, the economic benefit, and really, again, going back to the container value prop, agility, the ability to really speed your application development process by leveraging serverless. So serverless is coming on strong. With that said, even with containers coming on strong and serverless coming on strong, I'm always mindful that old technology for most enterprises doesn't get shut off overnight. Gosh, we even have tape libraries and mainframes, right? So, in that sort of context, what we're finding is that while containers and serverless do cannibalize the sort of the mix of server workload types in terms of VMs and bare metals, the mix of production server workloads is really a heterogeneous mix today, and it's going to remain that way moving forward. So now, there's always an exception. If you're a cloud native business, you've never seen the inside of a data center, so to speak, and you're building everything, you're a cloud native company, truly cloud native, you're probably not thinking about bare metal servers. You may be thinking about VMs like EC2, but most enterprises that are in transition still have some legacy technology, and that's why there's going to be a heterogeneous mix of server types moving forward. That obviously is relevant for thinking about the security controls that can protect the full stack of your legacy applications and your cloud native apps. Okay, so having talked about the composition of cloud native applications, the other thing we asked our survey respondents to weigh in on is what are some of the challenges in securing your cloud native apps? So all of you on the webinar today, being security professionals, know that, hey, there is no shortage of challenges. And so when I looked at these results, I sort of stepped back and said, okay, well, what's the theme here on the top challenges that the research participants are sharing? And really at a high level, and I appreciate this is basic, but really the challenges span every dimension of an organization's cybersecurity program. There's people challenges, there's process challenges, and there are technology challenges. If we start on the process side of things, the first one is really consistent with that notion that containerized applications, cloud native applications, will be deployed across hybrid multi-clouds. And therefore, the first challenge process-wise was maintaining security consistency across one's own data center and public cloud environments where cloud-native applications are deployed. So, hey, I want a consistent security policy, location agnostic, right? Now, it's pretty typical, we find, with the adoption of almost any new technology is sort of a siloed approach. I've got a separate team using separate controls or separate environments. We've seen that with container security. But what we're seeing now is because container security is sort of, or containers are critical mass, they're such an important fundamental part of the application infrastructure, is there's now a strategic imperative where there's a consistent policy approach across all these environments. So that's a process issue. Now, on the technology side, there's also the perception, the second one down, that, hey, I've got to use multiple controls, that increases complexity, or the one at the bottom, my existing security control doesn't support cloud-native environments. So that is indicative of a need to retool the security controls to support cloud-native applications. And then from a people perspective, there are a couple of ones here, right? One is, I got to revisit my threat model. So that's the third one down, right? I lack the understanding of threat types, attack vectors, methods, TPPs, et cetera, that put our cloud-native applications at risk. The next one down, we're going to spend a good amount of time on, which is our app dev and DevOps team don't involve the cybersecurity teams. I think cybersecurity is going to slow down the speed of DevOps. So no shortage of challenges, and they span all the pillars of an organization's cyber program. So then we double-clicked on the elements of a cloud-native application, right? So we asked, hey, when you think about all of the elements, including the peripheral elements, like the CSP that may be hosting a cloud-native app, if that is in fact public cloud delivered, the orchestration platform, the app code itself, as well as things like containers and serverless, what are you most concerned about? What do you think is most susceptible to compromise? And with serverless cloud functions and with the CSP themselves representing more than half the pie here, what I realized is it's a matter of control where organizations have concern. The less they can touch, feel, and control, the more concern they have. So that was interesting. And then the next question we asked was, we double-clicked on containers, right? So given containers are, broadly used, they're the predominant element of a cloud-native app, although serverless is certainly coming on strong. We wanted to really understand what the security concerns were specific to containerized applications. Now, this is also a question we asked 2 years ago, but 2 years ago, we did not have this top response option. And the top response option is really all about architecture. One of the things we see in early stage markets is there's often sort of a debate on the architecture, sort of the pros and cons and the implementation of a particular cybersecurity control. For example, in the cloud access security broker market, we very much saw this with a debate around reverse proxy, forward proxy APIs, and agents. I would argue your best coverage in that context is a multi-mode implementation. Similarly, in container security, we saw a debate around, the merits of a sidecar container, privileged container running actually in the container at the host level. And so when I started to think about, hey, organizations want optionality where their containers are deployed, and if they're consuming containers as a service with something like AWS Fargate, they're not going to have access to the host level. So they really need to be mindful that their security controls and how they're implemented are aligned with where their containers will actually be deployed, how they're going to consume Kubernetes and containers. And in fact, that came out as the number one container security concern is I need to align the implementation architecture of the security control itself with how we intend to deploy application containers. So it's good. It's good that organizations are thinking ahead that, hey, if I want optionality, I'm going to be moving my containers around, and I'm going to be consuming containers in different ways. I want to make sure the container security control that I employ has an equal level of flexibility. Now, other issues really align with the notion of securing the lifecycle, really the continuum of cloud-native apps, and in this case, specifically containers. And so the second one down is really sort of a pre-deployment one, right, which is I want to make sure that when I'm pulling containers out of a registry, that I've wrung out vulnerabilities. The other ones, as you're looking at the screen here, one of the things I would suggest is we've seen this movie before a little bit, right? When VMs hit and we had VM sprawl and we had fleets of ESX just sort of popping up all over the place, we had similar issues, which is, hey, I lack mature cybersecurity solutions for this environment. I'm worried about in this case, cross-container, but back then it was cross-VM container infection or VM infection. So similar issues that we had, years ago with VMs, we're now seeing with containers. Fortunately, we're well down the path in securing containers, really the full life cycle from pre-deployment into runtime. But what we're offering here is really what your peers are thinking and worrying about when it comes to container security. And again, top of the list is the need to align implementation of the container security control itself with how containers will be deployed. Okay. So similarly, on my comment about sort of no lack of challenges is also no lack of attack types that are of concern. And so we asked the respondents, what are the attack types that are top of mind for you? And again, not surprisingly, they sort of run the gamut here. Thematically, what I would say in terms of the attack types that cybersecurity professionals are worried about that are specific to the cloud native apps is there's the traditional vulns that we are still worried about, exploits to take advantage of unpatched applications and operating systems. But there's also some new types of vulnerabilities that respondents are rightfully worried about, things like misconfigured cloud services. So do I have externally facing workloads? Am I not using MFA for the console? To have an open object store? So that's all about sort of having good configuration management hygiene to be able to close off those vulnerabilities. And then things like the misuse of privileged accounts. That's not anything necessarily new. But in a cloud, at least a cloud context, access to the admin account or even service accounts, unfortunately, can give unfettered access to a wide variety of an organization's cloud services. So, a variety of attack types that are, on the brain, and some of them are, the unfortunately sort of tried and true ones that we sort of are in a, whack-a-mole sort of posture in. But there's also some new ones that are specific to a cloud configuration. Why the funny slide? So I live here in northern New England, and the leaves are coming down, and we're getting ready for snow. But it's not just because we're here to change the seasons that I offer up this picture. It's also because one of the common refrains in cloud security in general is the notion of a visibility gap. And the reason I think we often think about a visibility gap is because many of us, when we think about securing our cloud native applications or cloud infrastructure, we sort of ask the question, hey, where's the network tap, right? So we're sort of predisposed to catch it on the wire. It's like, okay, so where's the span port, the tap port? Like, where do I plug in my network security controls? And as we understand that, actually, the CSP handles that type of network security. You can have access to, flow logs and so forth, but you don't have access to the network as you used to. There's a concern that it's a visibility gap. I can see less now in the cloud than I used to be able to. So in this research study, we wanted to put some definition on the cloud security visibility gap. And what we found is that the top issue where respondents said, hey, I need to gain greater visibility into my public cloud footprint was really all around workload configurations that are out of compliance with things like this CIS benchmarks. So, being able to configure, Kubernetes itself, a container, a VM against the, well-known published CIS benchmarks is one visibility gap. Another one is having an audit trail of privileged user activity that connects with the related attack type of concern, and have an audit trail of system level activity, typically for compliance, but also for an incident response posture. So if you're doing an investigation on an incident or a breach later, you've got an audit trail for forensics purposes. Okay, so we've talked about the composition of cloud native apps. We've talked about some of the challenges in securing cloud native applications. We're going to switch from, sort of a problem-oriented discussion here now to how we solve for some of those challenges. And it's really rooted in implementing a secured DevOps program, sometimes referred to as DevSecOps. And the first thing we wanted to ask was the relationship or the correlation between Agile software development and DevOps processes. And what I expected, my thesis statement in asking these questions was that the dots were absolutely going to connect. It was sort of obvious that if I'm doing one, I'm probably doing the other, right? If I'm an organization that is writing user stories in Jira and I'm planning my sprint as a product owner with other members of my Scrum team, and I'm doing daily stand-ups, I'm doing that sort of all that iterative Agile software development processes. Similarly, I'm probably employing DevOps methodologies. I'm probably doing continuous integration and continuous delivery. And sure enough, what we found is 75% of the organizations that are doing one of these things extensively, either Agile or DevOps extensively, is doing the other one extensively. So these dots absolutely connect. One of the reasons I also wanted to sort of explicitly make that somewhat obvious connection is because one of the common questions I get is, where do I start? Like, if I'm implementing a secure DevOps program, where do I start? And I'll share with you later that some user stories. And just, I think one of the ways to start is with Agile user stories, and that the product owner needs to become a cybersecurity champion. But I'll offer a little more color to that in just another slide or two. So next question was, hey, are you incorporating security into your DevOps processes? And good news here. We definitely have growing adoption of DevSecOps. We've got 36% of the respondents that are doing this extensively. I mentioned that 2017 study we did, and so just to give you some time series data and how we've moved the ball forward here in 2 years, that was at 12% 2 years ago. So 2 years ago, 12% were doing this extensively. Now 36%. I'm not great at math, but that's a 3x increase. So that's good stuff. Now, at the same time, we have 22%, almost a quarter of the respondents that are planning to incorporate security into DevOps processes. We have another 20% that we're evaluating. So not quite half the respondents are trying to figure this out. And for me, what I think that means is we need to be prescriptive. We need to be specific on secure DevOps use cases, because one of the sort of rants around this whole topic is, what does DevSecOps mean anyway? And so I think we can answer that question by being specific with use cases that span the cloud native continuum. The other critical success factor in implementing a secure DevOps program is repeatability. And we gain repeatability via security as code. And we're really interested in John's comment on this later when he speaks. And I'll share with you, I was standing in line at reInvent for a session last year, and I happened to be sandwiched between two cloud security engineers. They both actually happen to work at very large organizations in the Midwest. And we got riffing on secure DevOps and their role. And they both came from the security team. They learned how to script. They're now embedded in Scrum teams. Both of them said the number one challenge is they can't support all their project teams. And so the way they're solving for that is they're writing reusable code, right? They're writing code for the different stages in different environments that different Scrum teams can then employ. That's how they get scale, is via repeatability, and that's what I mean by security as code. Okay, let's double click a little bit and get a little more specific. So in this survey, we asked whether or not respondents started implementing security use cases in the DevOps processes pre-deployment at runtime. Was basically a jump ball. So you can get on the secure DevOps train sort of at either stop. Both are legitimate. I think, as an industry, we've associated the term DevSecOps with the notion of shift left. That's certainly legitimate. And these are shift left related use cases. And if you want to start there, great. If you want to start runtime and automatically incorporate security controls in your build process and your orchestration automation process, and when you push to prod, you've got those runtime controls. That's great too. I guess what I'm saying is get started. Don't be overzealous. They're both legitimate, but over time you do want to secure the continuum. So get on somewhere to continuum, and then either shift left or stay right. Whatever metaphor works for you. But you don't have to do all this at once. The point is to really get started. And this is how some of your peers are getting started. So from a pre-deployment perspective, we've got a little over a quarter that says, hey, the first thing I'm doing is I'm doing software vulnerability scanning of registry resident container images. Now, it's directly correlated with the second top challenge around containers, which is I want to make sure I've got high integrity of containers I'm pulling out of, a public or private repo. I've got no software or configuration vulns. Hey, a lot of serverless coming on strong. Bigger part of how I'm using APIs, so 25%. I really want to be thinking about API vulnerability management, also software scanning in the build pipeline, and then moving forward, also doing discovery and inventory and auditing APIs that are used in all your apps. So this to me, this last one, the discovery of the APIs bit, is part of composition analysis. Ideally what we're doing pre-deployment in the dev stage is we know our bill of materials. We know what software components comprise our cloud native applications, from stuff we're writing on our own to third-party libraries, open source APIs, et cetera. We get a full bill of materials so we can then have visibility into what constitutes the apps and make sure we don't have any known vulnerabilities. Okay, what about runtime? So the runtime side of things, we've got a combination of sort of, access controls. The 26% said, hey, I want to make sure that I'm automating what tiers can talk to what tiers, so microseg or policy based on the host-based firewalls. I want to make sure that I'm preventing malware. Want anti-exploit capabilities. I also want, the vulnerability scanning I'm doing in pre-deployment. I want to continue that in runtime, because maybe I have some apps that are running that are not so ephemeral, that they're actually staying up in production for a while. So if 0 days come out, I want to be able to scan in production, see if I have any O days. And then IR, like I need to be recording system activity so I can do incident response should I have the unfortunate happen. So there are a variety of other runtime use cases that the respondents are employing as well. I wanted to offer another take on how to get started with a secure DevOps program by suggesting the series of Agile user stories by environment. So I'm just explicitly connecting dots with DevSecOps and Agile and suggesting that the cybersecurity team partner up with the project teams and the product owner, and that he or she is authoring user stories that are getting considered for the next sprint. Examples of that are integrating AppSec in your software development lifecycle. So like I mentioned before, doing composition analysis, static analysis, and then in your test phase or your integration phase, that you have an objective of reducing your attack surface at build time. So when you're kicking off Jenkins or whatever build tool is, that you're eliminating known vulnerabilities and you're hardening your configs of your workloads and your services. So so doing things like using a cloud cloud security posture management product, CSPM. And then finally, when you push to prod, that you've got policy-based runtime controls. So you're implementing things like least privilege, so reducing your blast radius and applying anti-threat, so anti-malware and anti-exploit. Anomaly detection is interesting, in auto-scaling groups. So things like kube clusters, where like all the entities are the same, or auto-scaling groups in a hyperscale CSP. There shouldn't be any deviation of baseline behavior, right? Should all sort of look the same. So anomaly-based approaches are important. Of course, you want auditing in a trust but verify context. Worth noting, naming conventions in this world are different. It's about tags versus IPs. So tags denote the role of an instance or a container, and also leveraging tags really provides like sort of a template, and then you're more consistent in policy. So that every time Apache web server is deployed in, say, eastern region of your hyperscale CSP, hey, automatically gets the same policy. You've got consistency by integrating with your orchestration tools that's pushing that application out. So those are some suggestions, certainly not by any stretch a complete list. It's just a way to get started on your program. Okay, so do we move the needle over time? I can imagine as an industry analyst, I look at a lot of research data, and fundamentally sort of have a choice of looking at it, from a negative lens or a positive lens. I'm an optimist at heart, so I'm always looking for the silver linings. And along those lines, I could interpret this research data, one of two ways. I could say to you, hey, only 8% of the respondents in this study are securing 75% or more of their applications vis-a-vis a DevSecOps approach. So that's true. That's not great. But what is really good is that jumps to 35% over the next couple of years. So I feel like, irrespective of how one may feel about the term itself, and I feel like the term gets thrown under the bus. I understand some of the reasons why that is. That there is goodness in implementing a secure DevOps program and integrating security into your DevOps processes, via which, it really starts with a cultural shift where security is treated like a shared responsibility. And the security team isn't trying to crash the DevOps party and sort of be heavy-handed in implementing phases and gates, because you won't be asked to participate moving forward. It's really, understanding the business outcomes that DevOps provides, the agility that we saw in the prior slide, where organizations that are using containerized applications beat their production schedules. So understanding that is the business objective, along with protecting that attack surface, and really partnering up with the app dev and the DevOps teams on starting to implement secure DevOps use cases somewhere along the continuum, and over time, securing the entire continuum. Which is to say, securing cloud-native applications really is a team sport. This is really what DevOps was all about, was breaking down the walls between the dev team and the ops team and getting away from throwing new code over the wall, and really bringing those two worlds together. And similarly, as we integrate security into that world, it's the same sort of approach. It's absolutely a team sport. Okay, with that, happy to hand off to John.
Thanks, Doug. So I want to give a little bit of an overview of taking Doug's research and making it a little bit maybe more practical in terms of what we have seen from customers and the kind of deployment patterns we actually see people using to validate a lot of the research findings that Doug was sharing with some more specific kind of technical examples. So when you think about this space, we always try to encourage people to think about cloud native as a continuum of different options. It's not simply about containers, nor is it simply about serverless. There's a lot of different underlying compute options that customers have. And what we see, the reality is that people are choosing the right option for a given workload. But why are they even moving to cloud native in the first place, and how does that change the security model? So if you want to go to the next slide, Doug. Everybody I think is aware of this notion of software eating the world, and you know that phrase from Mark Andreessen and others. Basically, that every organization is having to become a development-centric organization, a software-driven organization. It's not just tech companies, you know, banks and government organizations, healthcare. People choose who they do business with and how they interact with each other, in a lot of cases based on the quality of the software experiences they provide. And so if you take that as a given, basically, that everybody has to differentiate and gain competitive advantage through software, what are the tools that people are using to get that competitive advantage? And that's largely where this whole space of cloud native and DevOps becomes so virtuous, because as Doug was saying, you're able to ship that innovation much more rapidly. You're able to be more responsive to the market. You're able to really take advantage of that software that you're creating to have a real business advantage from it, versus just kind of creating it for the sake of technology. At the same time, you see that you know the world, as everyone I'm sure on this call knows, is increasingly dangerous, right? You continuously have more and more sophisticated attacks. And the third bullet that you see on the right hand side, I think, is really the most salient point, which is in this whole stack of what you use from cloud providers and open source providers, and you know the various components that you use to run these applications. The softest target in it is almost always your own software. You know, it's relatively difficult for an attacker to find a vulnerability in Linux or in Kubernetes, for example. Whereas if you think about the application stacks that people run their apps on, it's oftentimes a combination of a whole lot of open source components, things that they've built themselves. Some of those things may not be well maintained, and that really represents the weakest link in the chain, and why it's so important, as you were seeing in some of the previous slides that were presented, why it's so important to have that integration into the development process so you can find and prevent those problems before they actually make it out of development. Cloud native is not a kind of a good or a bad thing specifically, though. There's some things, like with any new generation of technology, that can make the job of the defender harder. There are other things that make it easier. So let's talk about each one of those separately, and you'll understand how this changes your overall approach to security. Cloud native makes things harder in a few ways. One of them is that it increases the level of infrastructure abstraction that you've got within your organization already. So everybody went through that journey 20 years ago, from physical to virtual, and then from virtual to cloud, or at least virtual in cloud. Now you're talking about putting yet another layer of abstraction on top of that entire stack. So in a lot of cases, when you're running containers or other cloud native apps, you're running those on top of one SDN that's provided by Kubernetes, on top of a virtual machine that may be using a different SDN inside of some kind of cloud provider. How those components communicate with each other is increasingly difficult in this space, because there's so much abstraction between what you interface with as an actual person, as an administrator, and the actual physical implementation of that. It just becomes more difficult because there's more pieces involved, more layers of the stack that you have to worry about securing. Further, though, everything in that stack is ephemeral and constantly changing. You know, if you think about the typical pattern that people would deploy applications with, let's say 10 years ago, somebody would log into some kind of deployment tool, they would set up a server, they would configure that server manually, and that server probably had a relatively long lifespan. It would run for months, if not years, with pretty much the same configuration associated with it, the same IP address, the same operating system version, et cetera. In this space, because the whole goal of it, again, is to accelerate that innovation, everything is changing on a much more frequent basis. It's changing because the developers are pushing out new builds. It's changing because the application is being scaled based on demand. But regardless of what the rationale might be at any one point in time, what you have today is almost certainly not going to be exactly what you have tomorrow or next week or next month. And traditional security tools will oftentimes have this kind of dependency, this assumption that there is a state of constancy within the environment that just doesn't exist within this cloud native world. And so when you think about securing this space, you have to have tooling and procedures that can deal with the fact that everything is constantly changing. Additionally, the things that are for if it's largely driven by one of microservices. In other words, you want to decompose your app into smaller and smaller units of functionality that can be individually iterated on and individually scaled. So if you had your standard kind of three-tiered web app that you ran in VMs, maybe you had, let's say, 6 VMs to do that. You had a couple of front-end, a couple of app tier, a couple of database ones. When you move that application to a cloud native architecture using containers and serverless, you may literally have an order of magnitude more microservices that compose that same application. So not only are they more abstracted, not only are they changing more frequently, there's just a lot more stuff that you have to deal with. Imagine if tomorrow you had 10 times as many VMs to manage as you do today. Obviously that poses a challenge for your security team. And that's really the reality when you transition to cloud native, is you have a lot more of those entities that you have to deal with. Additionally, the role of security and the responsibility for security becomes much more something that happens earlier in the life cycle, as opposed to the old world where somebody, again, would deploy that application and then the ops team would be responsible for using a tool like, let's say Tenable or Qualys or something like that to scan for vulnerabilities, and then the ops team would use a tool like BigFix or System Center or something to deploy an update to the application to fix those vulnerabilities. In this world, the developer is creating effectively a sealed artifact that they build themselves, and that artifact is what they actually deploy directly into production. And so there's not a separate team that's going to be able to fix problems in that artifact. The development team has to fix those themselves, which is why this whole notion of DevOps and getting development and operations closer together is more than just simply a buzzword. It's really critical to being able to use this technology successfully, because you've got to be able to have that integration from operations into development to be able to find and fix those problems. You can't rely on a separate team and a separate set of processes to do so. It's not all bad, though. If we go to the next slide and we think about what cloud native makes easier, there's a few things that cloud native enables that really have historically been this almost quixotic quest in security around better automation, more intelligence in the security platform. And there's basically this notion of being able to understand application intent and to automatically create a model that describes how an application normally behaves, so that you can move from that classic approach of security, which is trying to have a bunch of signatures and rules to, predict and prevent any potential bad thing, which is an unsolvable problem, to flipping that around to using something where you're really saying this is the only things that this application should normally do, and everything else will be automatically prevented. And the reason why that's possible with cloud native is three main characteristics. Cloud native applications are much more declarative in nature. So instead of it being just a kind of a bag of bits, some file that's basically opaque that I can't understand unless I'm the developer, cloud native apps by definition have a much more declarative approach. You're creating a YAML file to deploy them. You're using a Docker file to build them. It enables software to be able to read those declarative artifacts and understand the composition of the software in a much more reliable way than it's ever been able to be done before. Additionally, cloud native applications tend to be much more minimalistic. So just from a practicality standpoint, it's really hard for you to build a software security tool that can analyze a virtual machine image that may be 20 or 30 gigs. But now when you think about containers and cloud native, you're talking about artifacts that may just be a few hundred megs or maybe even a few tens of megs. So it becomes much more practical to be able to understand what they do, because their footprint on disk is just much more minimal. And finally, the entire operational model is much more predictable. In other words, instead of that approach that we talked about earlier, where somebody would deploy a server and it would go in and it would run for years, and that person may go in periodically and install a service pack or reconfigure the app or change the configuration of the operating system. In this world, the application, anytime you want to change it, you're destroying the existing running containers and you're reprovisioning new ones that include the changes you want. And that's such a critical aspect of this because it means that you version of the app, but instead for each version of the app, then you have this very trustworthy way to say, I know all the behaviors that this version of this app should be doing, and then I can look for and prevent things that are anomalous that are outside that model. But again, cloud native is more than just containers. If we go to the next slide and we think about this notion of a continuum, the continuum of cloud native apps is a concept that we try to use to describe the fact that it's not a journey. It's not like you're trying to say that you're going from virtual machines to serverless, but instead it's a set of different compute options for running workloads that each have their own strengths and weaknesses. If you look on the left side of that, for virtual machines provide the greatest levels of isolation and compatibility and control. If you have a legacy app that you want to transition into this architecture, maybe it makes up a component like a database that you're going to run, and you're going to have the application tiers and containers or serverless functions. VMs provide a really great way to be able to take that app and to run it in a way that's consistent, but without actually having to transform the application itself, because you have that compatibility there. Now, VMs, there's kind of the old world way of doing it where it's very manual, but there's this kind of newer way where you see people using things like CloudFormation templates and Terraform to really create and provision virtual machines as code, that notion of infrastructure as code. And that's really what we're talking about when we think about VMs in a cloud native context. Conversely, on the opposite side, you see serverless, which really prioritizes density and agility, simplicity. In the serverless function, you might be able to deploy it very rapidly and iterate on it very easily because it's just your actual application code, but you're giving up in that case the compatibility capabilities, the control that you might have with VMs. And then throughout this continuum, you see different kind of clicks on these options. So you have containers as a service platforms like Fargate, or at least like EKS, on-demand containers, which are probably more akin to Fargate, Azure Container Instances, PCF. These kinds of options, again, it's not a journey to say that virtual machines are legacy and serverless is the future and everybody's trying to go left to right on this continuum, but instead to say that every workload, that a wise customer is saying for any given workload, which parts of this continuum are best suited for its particular present today, being that organizations are having a mix of virtual machines they deploy through Terraform, containers, things that they run on Kubernetes, various managed Kubernetes platforms, serverless functions, that they're all using at the same time. And it's not a matter of saying which one is better or which one is worse. It's a matter of just saying which one is the right set of characteristics for a given set of capabilities. Doug, if we can skip forward a few slides to slide 33, which is enabling a better defense. We'll talk about some of the other advantages that Cloud Native provides here. So when we think about the defense that's capable, remember again that the notion is that you're able to create that model of what everything should be doing inside of the application, and to be able to then use that model to compare the real-time behaviors to what's expected. So the kind of the end result, the nirvana that you're able to achieve with this is, instead of you as a security team having to configure rules that say, my web application doesn't allow running Netcat, it doesn't allow running Nmap, it doesn't allow listening on port 81, etc. That's kind of the old world approach to security. You can now say that this web application I have, your security tool can automatically learn that it only runs this particular version of Nginx, that it only listens on port 80, it only writes log files to this path. It creates this model that describes all that, and then it's able to compare any attempted behavior that happens at runtime to what that model predicts and automatically prevent those things that are not part of the model. And again, the reason it's able to do this is because of those core characteristics of the underlying ecosystem that allow you to build these more automated, more intelligent security tools. The fact that containers and cloud native creates artifacts that are more declarative in nature, that are more predictable at runtime, and that are more minimalistic in the terms of their attack surface and footprint. Those three characteristics really allow you to create this model-driven approach that automates defense, that allows you to address some of those challenges that we talked about earlier, that you have many more things and those things are changing more frequently. If we go to the next slide, to kind of bring this part to conclusion, this new world of security is really about saying, how do you integrate that policy, that approach throughout the life cycle? How can you ensure that every time you're building your application, you're finding and detecting and actually being able to prevent compliance problems, vulnerability issues, that you're able to begin creating that model for what's normal, so that every time your developers are building an application, every time your overall DevOps team is deploying an application, it's already been checked for vulnerabilities as part of the build process. It's automatically being modeled for what it should be doing at runtime, and then throughout its life cycle, that runtime model is being enforced. And that approach allows you to scale across all the different clouds you might be running in. As Doug mentioned earlier, it's not just purely about public cloud. It's about being able to utilize these technologies and the security model across your existing data center, across multiple public cloud providers. One of the whole advantages of this approach is the fact that everything is really built around a set of open capabilities, open source software, and open approaches to running this that allow you to have that flexibility to run it wherever you may want to. So I'll turn it over to Doug to kind of wrap things up, and then we'll transition and take some questions.
Great, thanks, John. I really appreciate your point, by the way, on thinking about the application intent as the basis for a security model. I think heuristics, anomalies, and whitelisting have been problematic from an operational perspective in other application and compute profiles, and we're fundamentally talking about, to your point, John, like these are declarative entities where the role is clearly defined. There shouldn't be any deviation from standard baselines. The configs are locked down, and that's why a fundamentally different approach, anomaly-based approach, is really appropriate. So that was a great point. Hey, just to wrap things up here, I think one could argue we have too many terms in the industry today, and so I'm hoping to play a little bit of a translator in wrapping up today's webinar before we take some calls. We've heard this notion of cloud first. This is actually a term that was coined in the public sector by the U.S. federal government to really drive cloud adoption, that all new IT initiatives should be evaluated through the viability of leveraging cloud services. And so what we're sharing with you today is that, looking at today's cloud native landscape through a cloud first lens, is that the broad adoption of cloud services has really created a readiness gap. The adoption of these technologies we've been talking about is arguably ahead of an organizational readiness to secure them, and it really creates a strategic imperative to retool the program. Secondly, from a cloud native lens, the rise of microservices is adding complexity and heterogeneity. That's one of the points John just made, but also aptly, noted that there's also opportunity to improve our security posture by doing things like John mentioned, integrating with CI/CD, et cetera. And then from a DevSecOps lens or a secure DevOps lens, as I was sort of mentioning earlier, it really starts with a cultural shift, treating security as a team sport. It's a shared responsibility, and that's the organizational foundation from which the cloud native continuum can be protected. And then finally, the notion of security as code is, I think, how we get scale. We know we have an ongoing acute shortage of cybersecurity skills. It's even worse with cloud security skills, right? And so really to get repeatability and scale across multiple projects, that starts by creating code that we can scale across multiple projects. Wonderful. Well, thanks so much for participating and listening today. Mitch, I think we're ready to answer any questions that the audience may have.
Well, we've got some great questions queued up here from our listeners. First is, how do you see traditional security teams adapting to better work with developers? It's a good question. Actually, it's one that I can think about myself too, is, do security teams need to learn how to code? How do you get this sort of DevSecOps thing to really flow and happen?
Yeah, well, we've seen from a I was going to say from what we see with real world customers, it's not so much about teaching security teams to become developers, nor developers to become security teams, but really to have a shared set of goals and a consistent way, like a consistent operating model that basically satisfies both constituencies' objectives. One of the things that you can see in the screenshot on the slide right here is you want to be able to make sure that the security tools that you're building are not something that make it more onerous for developers to build their software. You want to build security tools that make it easy to fit into their CI/CD processes, that are easy to integrate with, that don't add unnecessary friction to the development process. And if you're able to create that tools and have a good experience for developers, At that point, you're able to talk to development teams and say, okay, now that we have the right tooling, now let's make sure that we put in the right kind of roadblocks, the right checkpoints to be able to say, every time that you're doing a build, we want to enforce that you've got this particular security model. So it's kind of both. Like, you have to build the software and the tooling in the right way so that people are happy using it. It actually doesn't slow them down. And then once you have that, you can utilize that framework to be able to actually push security further left.
Yeah, I couldn't agree more. It starts with approach. Both parties need to understand the other's objective. One, the dev team is charged with getting more code to production as quick as possible. Security team is responsible for mitigating risk. And then to John's point, the security team needs to be providing security controls to integrate natively with the dev tools, the DevOps tools that are already employed today to not introduce any additional friction. So it could be code scanning right in their IDE, could be native integration into their build tool, into the orchestration tools from runtime controls get pushed, and then codifying that and then making that repeatable.
Mm-hmm. I appreciate too also the shared goals comment I think John mentioned. Next question is, in ephemeral environments, organizations can struggle with visibility on multiple fronts. What are the biggest visibility needs, both from a lifecycle and runtime standpoint?
Well, I think from a visibility standpoint, at least from a life cycle perspective, the things that developers need visibility into are typically a bit different than the things that the security operations team would be looking at. Developers are mostly going to be focused on things that they can directly control, which is like the components that they have, the vulnerabilities may infect those components, and then the configuration of the images and functions that they use. Whereas security teams are typically more focused on the runtime aspect of it. But I think the question may be alluding to a point that I often make a lot, which is for all the discussion of shift left, which is an absolutely vital part of this whole thing. We spend a lot of time in this session talking about it. There's also kind of this notion you might call shift everywhere. I often talk. The idea is that it's great and vital to be able to find vulnerabilities early in the development lifecycle, but it's just as critical to have an efficient way to be able to signal back to those same developers that something that they deployed a week ago or a month ago that was fine at build time, there's now a new vulnerability that's been discovered that impacts that thing that's actually out there running in production. Historically, that was a very manual process. Somebody would, again, use a Tenable or Qualys or whatever, they'd run some report, they'd find these problems, and if they wanted a developer to fix them, they would have to go figure out what tool to update a ticket in and how to share that information. There's just a lot of overhead and friction, which made it much less likely that would ever be resolved. In this new world, because you have all this metadata from every build, that that declarative notion I was talking about earlier, you can have software now that says, even if this thing is fine today when you build it, a week from now, a month from now, whenever, when there's a problem that impacts it when it's running in production, not only does your security team know about it, but we can automatically reach all the way back into Jira or put a message in a Slack channel or open a GitHub issue or whatever it may be to notify the development team in their same native tools that they need to go and fix that problem. That's a really powerful kind of cyclical thing that you haven't been able to do in the past and this ecosystem enables. So shift left, saying you want to do security earlier, is a big part of it. But the other aspect is that kind of shift everywhere, to be able to say that when we have this metadata and we have knowledge of what's in production, we can much more efficiently go back to development teams and tell them they need to update something that may have been fine in that shift left phase.
Yeah, and I think the notion of shift everywhere is what we're talking about here in terms of securing the cloud native continuum. And I think the other concept to stir into the pot is the notion of immutable infrastructure. So it's ephemeral and temporal. Also means that it's typically immutable, that when you push to prod, you're not changing prod. John made this point earlier where, legacy apps, very often those servers are up and running for, months, if not years. In a cloud native concept, it's a state of constant change. And that's really opportunity, actually, that, before we push to prod in sort of a gold image context, we want visibility at build time to make sure we have known software or configuration vulns. So we have a hardened config that goes off to production. But as John just mentioned, new exploits, new vulns will be discovered invariably. And so you want to discover whether or not you have any applications running in prod that have that vuln. You go back and you shift left and you change your manifest or your config or bring up the vulnerability, whatever actions necessary to remediate pre-deployment, and you update and you push to prod. And if you're doing things like a blue-green cutover, actually aren't impacting availability, so you can still maintain your SLAs by using the CI/CD approach to rehardening, if you will, your applications.
Mm-hmm. Great, wonderful. A question came up, I think, during the talk. One of our participants asked was, why is container security different from VM or virtualization security? Is there a simple explanation for that? Is it a more complex topic?
I really think it's so, like the core things that you care about, vulnerabilities, secure configuration, runtime defense, all that stuff is the same in the sense of you still care about those same things. What's different is that the underlying technology is different, like the underlying stack, the ecosystem itself, which means that you have to adjust the tooling and adjust the approach that you take with it. We talked about the fact that containers, are much more ephemeral, that, that you've got a lot more of those entities. That's really the major area of change. The kinds of core things that you care about are really very common to what you're already familiar with VMs, and especially that point that I made earlier, that the softest target in all this is usually the code, the software that you run inside of that container. So it's not so much about saying you need to have this elaborate set of new defenses to protect your Kubernetes cluster, as much as it is saying, I'm going to be deploying a lot more software on a lot more rapid basis to a lot more entities. How do I scale out my security tooling and practices to be able to handle that?
Okay. Absolutely. There's also sort of an app store sort of dynamic here with containers, with public repos like Docker Hub, where you can go pull pre-configured containers out of those registries, a la almost an open source model. So it goes back to appreciating that you need to have a bill of materials composition analysis, and certainly if you're pulling containers out of a public registry, you want to make sure you're extra diligent, even if the manager of that public registry says that they are doing vulnerability scanning. You should take ownership for that before you put it in your private registry, and certainly before you push that to prod. So we had share VMs before, but I think there's more of a sort of a sharing open source app store kind of dynamic here vis-a-vis the public registries.
The old trust but verify, right?
Yeah, absolutely.
Next question is, if the continuum is becoming to be more predictable in the nature for native cloud environments, does this not introduce known points of attack or attack automation across the surface of an application container, i.e. the APIs or the controller interface? So I think what they're saying is, by exposing through containers, the architecture of it, doesn't that open up to a broader attack surface?
Well, I mean, the fact that you're creating a declarative way to do the deployment doesn't mean that that declarative model is available just to anybody that uses the application. A lot of that material that's being created is only available to the people that operate that cluster. It's not available to the people that consume the application. And so, now it does obviously introduce this scenario where if you had some sort of insider threat, or you lost access, or somebody compromised a repository where you stored all of your deployment YAML or your CloudFormation templates, and absolutely that becomes a much kind of a more of a keys to the kingdom sort of scenario than you may have had in the past. But that's not something that should normally happen. I mean, if you have your a repo where you're storing and Git, let's say, all of this deployment automation software, you would want to make sure that that's really treated sensitively, because it truly is something that you could use to have very broad access to the entirety of your environment. But that's not the kind of data that's just available to anybody that may be using those applications, or may just be kind of anonymously accessing them over the internet.
On a related note, the orchestration layer itself needs to be secured. So if you're using Kubernetes, that can be keys to the kingdom, if you will. So you need to make sure that your kube clusters are locked down and secured as well. It's not dissimilar from making sure you're securing your domain controller, or other means in which you're distributing software. So that infrastructure and orchestration automation software that's used is also part of the whole supply chain, and it needs to be secured and protected as well.
Well, thank you both. With that, I think we're coming up on the towards the top of our hour here. John, Doug, fantastic presentations, and appreciate the answers to your questions. We did have a few we won't get to, so we'll reach out to those individuals directly to follow up on those. And just a reminder, recording of today's webinar and slides will be available on Devops.com as well as via an email sent to participants. I'd like to thank our speakers today, John Cahill, Senior Analyst and Group Practice Director with ESG, and John Morello, VP Product with Palo Alto Networks. Today's webinar sponsored by Palo Alto Networks. It's been a pleasure to be with you today. Thank our audience for joining us. Have a great day and be careful out there.